Hello everyone, this is Ms. Shaista Khanum from Vidyavardhini's College of Engineering and Technology. In this lecture, actually this is a lecture of part of deep learning, which is a part of which is a subject of 7th SEM EXPC branch. So in this, I'm going to cover autoencoder, the application of autoencoder for image classification. So basically, what is autoencoder? Autoencoder is used for representation learning. In autoencoder, we have input layer, hidden layer, and output layer. Hidden layer is going to select important features, and again, output layer is nothing but going to regenerate those features. And like for example, if I'll take input as x as an image, then x is an input, then it is encoded using in the hidden layer, and then it is regenerated using the output layer. So we have x hat, and the x hat is a regenerated image, and the loss function is calculated between x hat and x, and based on the loss function the autoencoder is trained. So autoencoder, the one which we are using in this code, is nothing but convolutional autoencoder. In convolutional autoencoder, I'm using more than one hidden layer. So instead of using a using a hidden layer, I'm using a convolutional layer to extract the features. So mainly the main concept behind autoencoder is, like, if my x hat is properly regenerated, that means the autoencoder has selected the good features. So what I'm going to do in the image classification, here I'm using autoencoder for selecting a features. So here what I'm doing, I'm going to first of all train the autoencoder, encoder and decoder. I'm giving my input image x, and I'm going to regenerate x hat, and based on that a loss function is calculated, and based on the loss function the autoencoder is trained. Once my autoencoder is trained, after that I can say, if it is properly trained, my encoder is encoding the features properly, selecting the features properly. So next, in a next step, what I'm going to do, I'm going to use only encoder part of the autoencoder for classification. And in a classification model, along with the encoder, at the output I'm going to use a output layer based on how many classes I want to classify. And then I'm using this encoder as a part of the layers, means it is used to select the features, and then I'm going to do a classification. So now we'll see how we are going this doing this in this program. So first of all, at the start, here we have imported the important libraries. Next, here I've taken batch size as 4 and image height 224 and image width 224. That means I'm taking an image size of 224 by 224, and I'm reading the image in a batch size of 4. Here I'm using a data set, which is nothing but I'm taking a split of 0.2. That means I'm taking 80% training and 20% validation. And batch size, I'm going to read in a batches of 4. So this is nothing but trained data is my training data set, and val data is nothing but a validation data set. So here I'm using 3 classes. Then with the help of this, I'm going to read what is the length of the train data, validation data. So and then here I'm printing how many classes I'm using. Next, I'm, as the red file, the training data and the val.ds are the batch generator files. So I'm separating the uh, image and its label in X train and Y train, and val data and Y test is nothing but for validation data and validation. Y test is nothing but label of validation data. Y train is label of X train data. Next, here I'm this is nothing but what I'm normalizing the image. I'm as the image pixel is from 0 to 2 to 255, so I'm normalizing it, and I'm making the pixel values from 0 to 1. Then after that, next step is nothing but what, I'm splitting the folder. Now here, if you see, train x, valid x, train ground, and valid ground. Train x is nothing but my means after the splitting, we are going to get the four folders. Basically, when we split folder, so here we write x train is nothing but what your training data, and here we keep what is your expected output. But in this case, as in an autoencoder, what is your expected output? Your expected output is not, it should be original image. Like if I'm giving a image of a car, then I should get back the same image car. So that's why my x train and my instead of y label, here again I'm using x train only, because here you are going to get the same thing. So this is your expected output. Then with the help of this uh, uh, train uh, s- train and split, I'm splitting into four folders. Now next is nothing but what this is nothing but what my encoder and decoder model. In this encoder and decoder model, you can see I'm using convolution layer, and after that convolution layer, here there are different convolution layers that used, and you can see here I'm using 32 filters and 64 filters and 128 filters and 256 filters. And then in a decoder we are going to reduce from 256, I'm using 128, then 64, then 32, then 32, and then 1. So in this way, here we are encoding and then decoding. So this is nothing but what encoder, and this is a decoder. Now after that, here I'm using in this model, I'm using a compiling a model with a loss of MSE, that is mean square error, and optimizer, Adam optimizer I'm using. If you observe the model, you can see the model we are giving the input image as 224 by 3, and here we are coming it to the downside, 224, then 112, then 56, then 28, then 14, and then after 14 we are decoding. So 14, then 56, 112, and 224. So this is nothing but what you are getting the output. After that, this is nothing but a batch generator. Actually, the main use of batch generator, as if your data set, like for this example, I've considered only three classes, so that as such there is no problem. But when you work on a huge data set, then while training the model, you cannot load the whole data set at a time. So for that you need, what we need to load a model in a batches of image, so that your memory, otherwise what will happen, your memory of the, like I'm using a GPU, but your GPU memory will be full. So and you'll have a lack of memory. So for that we are using a batch, this is called as batch generator. So here I'm using a batch generator, and passing a images in terms of, here we have taken batch size of 4. That means in a batches of 4, the images will be given to the model for training purpose. So here you can see I have trained it for 500 epochs, and here I have printed loss and validation loss. You can see that the loss is continuously decreasing and validation loss is also improving. So in this way I have trained the model for 500 epoch, and I have checked the loss and validation loss. Then I have stored it as a .hy file, and this is nothing but what a training and validation loss. So this indicates that your training loss is continuously, and validation loss is continuously decreasing. Now next, I'm converting my labels into one hot encoder, right, encoding. So this is nothing but what a command to convert the my labels into the one hot encoding. And then here, after that, what I've done, again here I've applied split for x train, y train, one hot encoding. So here now I'm splitting the input image and its label. Now Now we are coming to the encoder part. So here, as I said at the start, that we are going to use, we have trained the encoder, autoencoder, for encoding and decoding. But now for image classification, we are going to use only encoder model. So here I have used, so what I have done, I have already trained the model. So I have tested that my encoder decoder model is working fine, because the loss function is good, it is continuously decreasing. So I have verified that this encoder model is working proper. So now, instead of using the whole encoder decoder which we have used over here, I am using only a encoder of this. And then after that, I'm flattening the last layer, and then I'm using a dense layer 128, and then at the end I'm using the num classes. So num classes is nothing but 3 I've used. An activation function, I'm using softmax, as we are using not, we are not working on binary, as we are working on more than two classes. So that's why the softmax activation function is used, so that it can give the probability of each class, ranging from 0 to 1. Then next step is used to this is, we have checked ki what are the weights of the autoencoder model. And what we have done, we have here layer dot trainable equal to false. So here we have freeze the layers. So these layers are freezed. And after that, after this food model, I'm using the compile, and I'm now using categorical cross entropy loss, and Adam optimizer is used, and matrix is accuracy, so that it is going to display along with the losses, along it will display the accuracy also. Now if you see the full model, so in this full model I have used 224 to encoder model. So encoder is 224 224 comma 3 input, that is making it down to 112, as I'm using convolution, and then max pooling. Then 112 to 56, 56 to 20. Okay, sorry. Just I have used till 56, and after 56 I have flattened it. And after flattening, I've used 128 dense layer. And then here I have used two classes. So here I'm using two. Just check it once again. I think so. I have at the start I've taken three, so it should be three. So that can be done. And after that, now using a model dot fit command. So model dot fit command, here I'm passing a train x and train label, as and the validation mein I'm valid x and valid label. So you can see here I'm running it for 40 epochs. So here you can see the accuracy is continuously increasing, 90, 96, 98. And the important thing, the validation accuracy is 85. If you see at the end, after 40 epochs, the training accuracy is 99, and validation accuracy is 84. So still there is around 10 to 12% of a difference between the validation accuracy and the training accuracy. This indicates that the model is overfitting. So you can work on this model, and you can avoid the overfitting by using, like, you can introduce the dropout layer, and different overfitting you can use overfitting or L1 regularization, L2 regularization. These things you can use, and you can improve the model. So in this way, here we have seen how we can use autoencoder for image classification. So try this code, and the data set and the code is available in uh, a link. I have given a drive link, so you can take the data set and the code from that drive link. Thank you so much.